So let's have a look at how we can find the general term of a quadratic sequence. So we're going to write out the sequence first of all, which is 12, 16, 23, 33, and 46. And that sequence obviously goes on. So this is my sequence. I'm going to find the difference between the terms. So if I subtract 12 from 16, I get 4. Subtract 16 from 23, I get 7. 23 from 33, I get 10. And 33 from 46, I get 13. And you can see that, the next difference would be 16, the next difference would be 19, and so on. So this is the first difference. Now the second difference is the difference between those terms. So the difference between 4 and 7 is 3. The difference between 7 and 10 is also 3. And the difference between 10 and 13 is 3. And so we can see that the second difference, or the second change, is a non-zero constant, which makes this a quadratic sequence. Now, how do we use this information to go and find A, B, and C for our general term? Well, the second difference is always equal to 2A. So we're going to write down that 2A is equal to 3. And so A then would be equal to 1.5. So A for our general term formula is always half the second difference. So if I write down our general term formula, an squared plus bn plus c, we found the A. The A is always half the second difference. And so it's going to be 1.5 n squared plus bn plus c. So we update our formula to account for that new information. And the rest of the question is going to be to find the values of b and c for this general term. Now I can see in my sequence that the first term is 12. T1 equals 12. And so what I'm going to do is I'm going to write that down. And I'm going to sub n equal 1 into my modified formula and let that equal to 12. So I'm going to take my formula for the general term, 1.5. Where I have the n squared, I'm putting in 1 for term 1. Plus b times, again I have an n, I'm going to put in 1 for term 1, plus c. And I know the value of term 1. Term 1 is equal to 12. That means that when I put 1 into my formula, it should equal 12. I'm going to tidy this up, so 1.5 times 1 squared is 1.5, plus b times 1 is b, plus c is equal to 12, and then I have b plus c equals 12 minus 1.5, which is 10.5. And I'm going to call this equation 1, and I'm just going to leave it for a second. Well, similarly, I can see that the second term in the sequence, term 2, is equal to 16. So if I write down that term 2 equals 16, and I take my general term formula, Tn equals 1.5 n squared plus bn plus c, and sub 2 in for n, well then that should be 16, because 16 is the second term. So I have 1.5, and then for n I'm going to put in 2 squared, plus b times n, which again is 2, plus c, and the second term in this sequence is 16, so when I sub in n equal 2, the result should equal 16. So tidying this up, I have 2 squared is 4, by 1.5 is 6, plus 2 times b is 2b, plus c equals 16. I'm going to subtract 6 from both sides, give me 2b, plus c equals 10, and I'm going to call this equation 2. So to solve for b and c, I'm just going to solve this simultaneous equation. So solve the subsequent simultaneous. So I'm going to put equation 2 on top just because it has a larger b value. So I have 2b plus c equals 10. And then I'm going to multiply equation 1 by minus 1 so that I can eliminate the c's. And so multiplying all of equation 1 by minus 1, I get minus b minus c equals minus 10.5. I'm going to draw a line underneath. I can eliminate the c's. C minus c is 0. 2b minus b is 1b, and that's equal to 10 minus 10.5 is minus 0.5. Now that I know b is minus 0.5, I'm going to sub that into equation 1, which is b plus c equals 10.5. So b is minus 0.5, so minus 0.5 plus c is 10.5. And then adding a 0.5 to both sides, I get c is equal to 10.5 plus 0.5, which is 11. So now that I have values for b and c, I can rewrite the general term as t of n is equal to an squared, which is 1.5n squared, plus bn, which is minus 0.5n, plus c, which is plus 11. Now, when you get your general term, it's a good idea just to test another of the terms in the sequence. So we use t1 equals 12 and t equals 16. We could have made simultaneous equations out of any of the terms that we had. We could have subbed 3 in for n, for example, and let it equal to 23 to get another equation. But we can use this formula now just to test for term 3. So if I put down term 3 is equal to 1.5 by 3 squared minus 0.5 times 3 plus 11, I'd hope I get 23, which is the third term, and this will just show that our formula is right. So t3 is equal to 1.5 times 3 squared is 1.5 times 9, which is 13.5, minus 0.5 times 3 is minus 1.5, and then plus 11. So term 3 is equal to 13.5 minus 1.5 is 12, and 12 and 11 is 23. And this just confirms that our formula is correct. If we were to sub in 4 for n, we'd get 33, 5 for n, we'd get 46, and so on. So the second part of the question is very straightforward. We have Tn is equal to 1.5n squared minus 0.5n plus 11, and we're asked to find T30. So I'm just going to sub in 30 for n, so 1.5 by 30 squared minus 0.5 times 30 plus 11, and I'll throw all this into the calculator to give me that the 30th term is 1346. And so that's the beauty of finding the general term of a quadratic sequence. We can find the value of large term numbers without having to write out the numbers as far as, for example, 30 in this case.